Welcome back, Physical Science 20. This is the second video. So we just talked about image distance and object distance. Over here we have high and ho. So HI, height of image. HO is height of object. So those are things that we'll be talking about in these diagrams. So of course, if this is a candle, it appears that the candle is on the same side of the opposite side of the mirror. Our eye seems to think that it's coming from there, but of course it's coming from the mirror with that incident ray being reflected off there and us seeing the reflected ray. The two rays from point O at the tip of the candle. Let me just move this here. So we have that two rays strike the mirror at P1 and P2, so P1 and P2. Both rays are reflected according to the law of reflection. The reflected rays are extended behind the mirror as sight lines, converging at point I, which is the image of point O. Okay, so image is there from point O. Ray 1 strikes the mirror at an angle of incidence of 0, is reflected back upon itself, so the sight line is 90 degrees to the mirror. So that's just this ray talking about here. Ray 2 is reflected at an angle equal to the angle of incidence, so that the sight line is the same angle as the mirror as ray 2. All right. This geometric model reveals that line segments OP1 and IP1, so OP1 and IP1, these segments are two congruent triangles. The position of the object with respect to the mirror or the object position has a length equal to the length of OP1. The apparent position of the image with respect to the mirror, or the image position DI, has a length equal to IP1. Using this convention that image position is negative to indicate the image is virtual. So what we often do is we say that DI and DO are equal, DO and DI, but anything on the opposite side of the mirror or appearing to become behind the mirror is considered to be negative. Everything on the front of the mirror is positive. So plane mirror image position. So DI is equal to the negative of DO. So for example, if distance of object was 4 centimeters from the mirror, and if we measure, that would mean DI has to be negative 4 centimeters. And then when I apply this, DI is equal to negative of DO. DI, negative 4, is equal to what DO is, negative. Yeah, so mathematically, that's how we get that to be true. We have to treat image distance as negative. You can draw rays from the object to the mirror to determine the size of the image. The sight lines of two rays originating from the bottom of the candle in the previous figure will converge at the bottom of the image. Using the law of reflection and congruent triangle geometry, the following is true of the object height, HO, and the image height. So we can see here that they are equal. So even though it's behind, this height and this height are equal. Okay, so it's just distance of image is negative. If this is 10, then this is 10. So HI equals HO. Image orientation. A plane mirror produces an image with the same orientation as the object. So you see he's not upside down, what that means. So it either means upright or inverted. And again, when we take curved mirrors, we'll see that we can have inverted. If you're standing on your feet, a plane mirror produces an image of you standing on your feet. If you're doing a headstand, the mirror does the same. However, there is a difference between you and the appearance of your image. Follow the sight lines in the figure on the right. The ray that diverges from the right hand of the boy converges to what appears to be the left hand of his image. Left and right appear to be reversed by a plane mirror. Why? Then are they not top and bottom reversed? This does not happen because a plane mirror does not really reverse left to right. The mirror in the previous figure only reverses the boy's image such that it is facing in the opposite direction as the boy, or what we say is it's front to back reversal. So plane mirror image attitude, by the word attitude, what we really mean is orientation, whether it's upright or upside down. And by upside down, we call that inverted. It's upright. And then the plane image type, with the plane mirror we mentioned earlier, that is virtual. Appears to be behind the mirror and cannot be seen on a screen, as we'll see later on. So we'll be looking at completing some of these ray diagrams. There's a couple of steps which will make it easy. So find the image location by drawing a perpendicular line from the object across the mirror. Make sure the image is located an equal distance behind the mirror as the object. If the object is complex, we can do that for more than one point. In the examples, I think I do that with one of them. Draw a line from the image to the eyeball, such that it is a dotted line behind the mirror and solid in front. Draw a solid ray from the point of incident to the object. Add arrowheads to represent the real path, and then if we have more points, repeat that. All right, so what we'll do is we'll do this for 2 examples here. Use the steps above to locate the position of the following image and illustrate how the eye sees the image. Use a ruler and a protractor if possible. Okay, so I could do that. I have a ruler here and just going to grab a protractor. There we go. So here we have, so that first rule, we'll keep the rules here handy. Find the image location by drawing a perpendicular line from behind. Okay, so if I look here, you can kind of use your ruler here. So for example, I could, so see this line right here? I could line it and overlap it with the mirror itself there. Now I know any line I draw is going to be perpendicular. Okay, so I'm just going to use a pencil here, solid line, and then make it dotted in behind. All right, so and then measure, because I want it to be an equal distance. So let's see here. So again, make a perpendicular line. You can do that by using one of the lines on the mirror and overlapping it on the mirror. Measuring this, let's see here, to the edge of this circle here, it's about 1.40. So I need to go 1.40 on the opposite side. 1.4, so make it there. Let's maybe look at how far it is from the mirror to this side. 1.80. So 1.80, so that's circle. So I can draw that big circle, and then there's an inner circle there too. So let's draw it something like that. Okay, so that's the first 2 rules there. So drawing a perpendicular line, make sure it's equal distance behind the mirror as it is in front. You could redo this for more than one point, but since it's only kind of like one big pointed object, I'll do it just once. Here I'll do it in 2 locations, here and here. Draw a line from the image to the eyeball. So it's a dotted line behind, solid in front. So now I'll just take the middle of that image and draw it to the middle of my eyeball here. So it's dotted behind and solid in front. Okay, so I have that. And of course, technically it's going to the eyeball, and the eyeball thinks it's behind the mirror. Draw a solid ray from the point of incidence to the original object. This here is the point of incidence. Point of incidence. So I go from there to the object. Then the last step is add arrows. So technically the light is bouncing off the object, hitting here, then hitting me in the eye. And of course I could draw normal here, and I could measure, and I would see that that angle I is equal to angle R. Angle I and angle R. But it doesn't tell me to do that in this case, but I could. All right, let's do the same thing with this one. I'm going to do it in 2 different places this time. So again, draw a perpendicular. So again, get a line here, line it up with the mirror. Good. And now it's equal distance. So let's see here, 2.10. 2.10. So there it is. Let's do the same thing with this arrowhead. So I'm just going to draw this a light line. Oops, I guess I should do this first. Light line, dotted. And this arrowhead appears to be 3.60. So 3.60 approximately. So 3.60. So the image of this arrow looks like that. Image, I guess I could have done that here too. Image. Okay. Now, pick each spot separately here. So I'll pick this one, and this is one I did first. So the tail of the arrow tends to originate over here. So dot, 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 solid to my eyeball. And of course, it actually came from here, rebounding off the mirror. So solid there. So the light hit the tail end of the arrow, hit here and hit here. Do the same thing with the tip of the arrow too. Dotted, 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 solid to my eyeball. So here's the point of incidence of that part. So I just extend that back to where it actually came from. And it looks like that. Okay, so you may have to practice that a little bit. On the assignment, I have some practice questions. Should be able to do that. And of course, angle I would equal angle R here. And this one, if I drew the normal, angle I equal angle R, I'd be able to figure it out. All right, so go ahead, do the assignment, and we'll see you again.